Okay, back here at the K-model cases, we're making K-models great again. And old Sportsters. So I'm going to put some lube on here and tell you about this Wohlhaupter head. So this is a German-made Wohlhaupter automatic facing head. It also bores, but I prefer to use the Criterions or the more boring head for boring. So I only use this for facing generally. And this head is a UPA 5, and it's too big to use on a Bridgeport. So if you're shopping for one of these heads, you just got to know the distance, the longest distance you're going to be cutting. Like this might be 2 inches. So a UPA 2 would do it, but probably a 3 would be better. But this is the head I have here. I got this from the Boeing surplus store in Kent, Washington in the 1980s. They discontinued using jig borers. So I got that pretty well lubed up there. And the holes in this are 7/8 of an inch. And I make my own cutters for this thing. And this is made from a 7/8 inch hitch pin. And I ground it and machined on it, and I brazed in, you can see, an old carbide insert. And the boring or facing head that's in there is a little shape just slightly different. This one here cuts up to a lip, and I use this for cutting up to the lip on big twin cases. So I just thought I'd show you that. Yeah, I fabricate my own tools because they work better that way. So to get this thing to work, there's this collar here, and there's these pins, and with this tool, I'll push a pin in. So every pin you push in feeds 1/2 thousandths. So I want this thing to feed a thousandths, so I'm going to push a pin in over here on the opposite side. Now it'll feed a thousandths. You know, if you wanted to feed 2 thousandths, then you have to push in 2 more pins. Or 3 thousandths, you know, you have to push in 6 pins. So let's get it going. I got it set at 5 thousandths depth. And you see this collar here with the pins stays stationary. So this will face like a lathe. And let's start it up and start facing. Let's see how we're looking. Looks okay. Now, sometimes this thing, when it's cool, roll up my sleeve, because I'm going to keep my hand on this collar here and keep the button pushed in because it's a little bit cold. We'll see if it feeds. I'm going to do it by hand, rotate it. Everything seems to be a go. So here we go. I'm going to run at about 260 RPMs. Oh, got to put it in gear. There it is. And you'll see it start to feed. I'm not sure if it'll clean up at 5 thousandths depth, but I think it will. You see that? It's a cutting nice. Looking real good. Nice finish. Now, when I'm talking about it cutting like a lathe, I'm not kidding you. I might do a 2000s finish pass, and as this feeds out, the tool pressure slightly lifts and it makes a concave surface like a lathe's supposed to do. And that's ideal for pressure sealing. More than a convex surface will blow gaskets out. So this is slightly concave, and this distance perhaps about 2/10,000ths. If you loosen the gibs on the slide, it'll give a little bit more, so you can control how concave. I think it's looking great. Completely cleaning up. Almost at the edge. You gotta check for clearance because this thing's feeding outward. 269 RPMs. I can run this thing up to 400 on this machine before it starts shaking. It's starting to shake a little bit, but we're looking good. Almost to the end. Looking good. I got plenty of clearance, we're going to be okay. If it starts smacking the case, I got to shut it off quick, huh? Looking good. Plenty of clearance. Alrighty. That's it. All right, let's see if I can just kind of dust that stuff off. Yeah. Now the retail price on this head, now I'm gonna go just slightly more. I'm gonna feed it in, about another 2/1000ths. And I think that'll be good. I got a little spot here. And I don't, this is the worst surface. So if I clean this up and then use the same feed or depth, when I rotate this, it'll cut exactly the same and keep it the same distance from the center of the crankshaft line. So to return it, all I have to do is just turn it back here. Let me get it out of gear. You can see the feed screw right there. And I'm just going to run it all the way back. And I'm going to feed it in. I'm going to feed it in 3/1000ths. There's plenty of room here. Not going to cause any problems. Very good. So I'm going to feed it in. I've got a little Mitutoyo gauge on the quill here. There we are. Right there. Looking real good. I'm going to slow the speed down just slightly. This is a variable speed Reeves drive, so the machine has to be running to adjust the speed. Get some of my special cut and wax all the way around. So as this slide feeds up, the tool pressure pushes up and you get a convex surface, which is ideal for sealing cylinder head surfaces or anything. And like I said, if you want a little bit more convex, then you loosen the gibs on the slide. Kind of makes sense, doesn't it? Okay, I'm going to keep the feed the same. Put it in gear. It's in gear. I'm going to fire it up and drop the speed a little bit if the pin stays in. Looking good. Here we go. Okay, I dropped it. I dropped a little more. 230 or 220. It's actually shaking the machine a bit here. Nothing to be concerned about on this particular job. And are we cleaning up that little spot? Absolutely. So I'm going to end up, I'm going to drop it slightly more. 198. What a beautiful job this thing does. So I've had to cut this down 8.5 thousandths. This is the most uneven surface from the mismatch of the cases. When I rotate it for the rear cylinder mount, I'll feed it in exactly the same. So nice. Now, if you don't have this, you can fly cut it and be sure your tool's real sharp and you'll be okay. Now, I use this to face cylinder heads, both 4-stroke Harley Davidsons, and I used to use this to face the 2-stroke heads. Two-strokes seem to have been replaced way back when I was doing stuff in 06. After 2006, I pretty much stopped doing all motorcycle work and did work for hydraulic shops and the equipment companies here, particularly Case was a real good outfit to do stuff for. I never did a thing for John Deere. They seem to just replace parts, not rebuild anything. This whole thing's just kind of shaking. It's pretty cool. The machine's heavy enough that this is not going to cause much problem, if any at all, on this. But I could counterbalance this head. But we're just going to finish it up. Very, very good. Holding the depth. Plenty of clearance. Don't want to hit that generator here. Completely cleaned up. And that's how I do it. I'll kick it out of gear. Return the slide. Pull it up. Yeah, see, it's just beautiful. Completely clean. Nice and shiny. People would wonder how I'd get this kind of finish back in the day. And I wouldn't tell them. You turned that on a lathe. How did you get that in a lathe? I had a big old lathe too back then. Big old Lodge and Shipley power turn. Had almost 20 inches of swing. This Axelson I have here has about 16 3/4. Okay, I'll take that loose. Have a quick look at it. Look how pretty it is, huh? Look at that. Isn't that sweet? I call that a finish to die for. Nice finish inside, nice finish out. When I was doing work for other shops and stuff like that, they just love this. Because remember, people are like bowerbirds. They like shiny things. So sometimes when you're doing work, you might want to put a finish cut on some things that might not be necessary just to make it shine. And another rule of thumb is when you do something for somebody, don't give them something that they're going to get cut on, because that makes you look bad. So I'd have to take and deburr this. It's razor sharp here, this edge. Okay, we'll be back for the rear cylinder surface. There, I'm plugged in, I think. Hopefully the sound's working good. Now I got this rotated over, and I got to feed it in 8 thousandths, 8.5 thousandths. And I'll take 5 first. Get some wax on here. Now this is slightly offset. It's going to cut on the front side here first. And then it has to stop by this notch here. So it'll start cutting a little bit on there. And I think I'll put this on the DD channel, just showing facing with the Wohlhaupter here. Now, I'm going to, since I had the head installed, I'm going to go ahead and face this, and then I'll put the standard boring head in and open up for the cylinders there, as I had to squeeze these case halves together from warpage, damage, whatever. So get this in a good spot. I got everything leveled. I got jacks under there to support this. It's all square, looking good. I'm going to feed it in. Right there. Right at 5. Okay. Everything, I believe, looks good. I got a brass counterweight on the end there. And here it goes. Now you can hold this totally by hand, but I've got a support rod going in between the vertical ways. On this Moore number 2 jig bore, running 180 RPMs. Getting a little bit of shake out of this. The feed is 1/1000th. And it's starting to cut. Looking really good. Yeah, this is a 5-inch Wohlhaupter UPA5. It's a real chunk of metal. But for the most part, this jig bore handles it just fine. I think a UPA 3-inch head would do this job. But you might have to offset a tool. Yeah, just purring right along, making a real nice finish. Yep, looking good. Now, one thing you can do, if you have to squeeze these cases together considerable, you can put steel inserts in for the cylinder studs and move them outwards. But I don't think I have to do that. I might just have to slightly grind on the cylinder stud openings just slightly. But if you're doing later model Sportster cases that got long studs, and have to squeeze those together, you'll likely have to put steel inserts in for the cylinder studs and then move them out. So the studs will slip through the cylinders and the heads. I only had to squeeze this together 50 thousandths. And that's not a problem. It's under 60 thousandths. I've squeezed these things together, a bit over 60 thousandths in the past. Doing that extremely good finish. Now, like I said, it works like a lathe. Lathes are set up to cut a concave surface. A convex surface won't sit flat. And a convex surface will blow gaskets out. So this leaves a slight convex. As the slide moves out, the dynamics of it has more leverage and pushes the tool up slightly. Looking excellent. The machine's shaking less with that counterweight. This machine weighs 4,000 pounds. The horizontal mill over there, I can use this head in both the vertical head attachment, almost where I'm supposed to be here. It's got to cut clear across the top, but stop before it hits this chain case. Looking very good. So this leaves an ideal finish because of the convex surface. And hopefully if you're using a fly cutter, you'll get a flat surface. Okay, I cleared it, we're done. Now I'm going to move it back to center. Just like this. Take it out of gear. It's got a clear, it's just slightly off center because of the shape. But it leaves that nice finish. How are we looking? We got clearance. Okay. So I'm going to put this lube back on there. Dust that off a little. Yeah, this is going to be okay. Okay. Dab that stuff on there. Now I'm going to feed it in the rest of the way here. We're at 5.5. I've got to go 8.5. And 8.5. Almost. Okay, there we are. Looking good. Back in gear. And give it a shot. Here we go. So this will cut internal grooves very easily. Each one of these pins you push in is a 1/2 thousandths feed. I got 2 pins pushed in. So the feed is 1 thousandths, the speed is 180. Okay, we're cutting on that front side. The balance is real good with that counterweight in there. Almost cutting all around it now, complete circle. Now the left case is just a couple thousandths higher than the right case. Absolutely insanely good looking. What a beautiful finish. Now I had fixtures that I could do the Harley Davidson cylinder heads like this and put that finish on it. Now one guy that does cylinder heads, really pretty well known person, finishes cylinder heads in a lathe to get this. But this makes it a lot easier. So I did 2-stroke cylinder heads like this, and did the angles that they have, a couple of angles sometimes in a dome, and I did those angles with the tree angle cutting head. Both of those heads can be used for boring, but I prefer just a direct reading head like the Criterions, or for higher accuracy, the more. I don't particularly like boring holes with this head because it's got that gear mechanism. It's got a star wheel in there that these pins hit, which goes back to the most ancient times in machining. Now the machine's just starting to almost shake a little bit as I get to the end here as that slide extends. I tell you, back in the 80s, nobody knew what this thing was, these Wohlhaupter heads. Before I had this jig borer, I ran this on a horizontal milling machine doing the same thing. And how we looking? That top is completely clean. Okay, we'll take it out of gear. Let's have a look at it. Dust it off a little bit. Okay, I'll remove the Wohlhaupter and put it back in the Criterion S3. Be back soon. Oh, so nice. Look at that. Nice and shiny. Okay, I am back here, and this may be the start of the video on the DD channel. Now, the Wohlhaupter head leaves a concave surface, ever so slightly concave, like a good lathe is supposed to do. And sometimes I get concave and convex mixed up. But the Wohlhaupter head leaves a slight concave. So I kind of got the words mixed up in part of the video. So just to be clear, the Wohlhaupter head leaves a concave surface, which is ideal for gaskets, because a convex is like a hump and it'll blow gaskets out. So I thought I'd clear that up. Okay, now I got this is the last cut, and I'm going to punch this out so the cylinders will fit in here because I had to squeeze the cases together. So let's get cutting there. And in here is a Criterion S3 head, and I make special cutters like this. They're hollow. Here's the cutter here. That way I can get a diameter without offsetting the head too much. And these square heads are quite rigid, but they only have one hole right in the middle, okay? So we'll start cutting it. Get it in gear. In gear. Get it going. Now I'm going to speed it up about 400. About 396 should be okay. Get the clutch engaged. I'm going to bring it down. See how it's looking. I got a fine feed on it of 8/10,000ths. See if we're going to get cut in here. Right there. Power feed. Looks like it's doing pretty good. If it starts humming too much, I'll slow it down. Looking very good. Just about got this thing wrapped up here. And I'm quite happy about that. That's doing okay. All locked up, all level, centered. Very, very good. Yeah, this is the last step here on the major machine work. And I call this pretty much major machine work. Relocating the dowels on these mismatched 1953 K model engine cases. Both cases are 1953, but were not matched at the factory. Just some old junk that got put together, and I think I can turn this situation around and get a motor that'll run. But I'm going to detune it. These things had quite a bit of horsepower, being that the cases had been busted and welded and all this work done to it. I'm going to just kind of drop it down a little bit so it's not going to eat itself alive. Just about through there. I'm going to take a couple, 3 cuts here to do it. And the diameter I'm looking for is 2.994. And that'll give it about 5/1000ths clearance for the protrusion or skirt on the bottom of the cylinder. Yeah, doing all right. Okay, I think it's through. Hit the brake, bring it around, feed it in. There's my tool. Okay, take about 20/1000ths, it's 10/1000ths on the side. Make sure that the screw's tight. It is. Good enough. Okay. Get a little more lube in there. Right there. A little dabble-dee. Okay, here we go. I'm going to hand feed it down until it touches. I might have to back the speed off as it makes more contact. Yeah, I'm going to drop it down a little bit. 280. seems to be happy enough. Oh yeah. Now, this whole thing I'm doing here with these cylinder surfaces would be much easier on the horizontal milling machine, where I could lay this down rather than standing it up. It's always easier to lay things down than stand them up, but I went ahead and used this because this would be more like you would do on a Bridgeport, or you would have to do on a Bridgeport. Most people don't have horizontal milling machines these days, but I find them indispensable. Really glad to have that old Brown and Sharp horizontal milling machine. Things are looking very good. Yeah, being mismatched, it showed up on the cylinder mount surfaces, and to make things really good, it's just good to machine them. And I'm basing everything off of this left case. The left case being the most valuable part of the engine, because it's got the title and the VIN number. So I want to do everything to preserve this left case, which, by the way, has the most damage. It'll be a relief to be done with this phase of this. That's a considerable amount of work. I played hooky out of here for a little bit, had some good weather, and got out and got the dogs exercised, and walked up in the hills. Very, very nice. I like being outdoors. Just almost midnight here right now. I hope your projects are going good. Oh, it looks so good. Very, very nice. Punching it all the way through here. And that's it. Okay, I'll kick it out of gear. Crank it all the way up. I want to see what a measurement is here. See where we're at. Got just about 10 thousandths to go, 11 thousandths. Oh, there we go. I'll go ahead and take it. Right there. More of that magic wax, beeswax lube here. Beeswax and Castrol Molly D. Some tap magic in there. A couple of extra toxic ingredients. There we go. Get it back in gear. Hit the button. We are. Yeah, I got just a little bit less than 1/1000th of an inch feed. Running at 262 RPMs. The Criterion S3 square head. Got a 1-inch hole for the tools. I prefer these square heads over the standard ones because they're more rigid. They're shorter, more rigid. But I have to make my own bars for them for this application. But I make my own tools anyway. If you make your own tools, they can't call you a shake and bake machinist. Now, a funny thing about this, I'll tell you, I know other people that could do this, that have done this, but they're not going to do YouTube videos. Not willing to. There's people out there who know a hell of a lot more than me, but they're not willing to do videos on YouTube. See, I almost died of cancer in 2016, and after that, I just don't care. It doesn't bother me a bit. I have fully recovered from that dreadful disease. I had 11 major surgeries. I'm hard to kill. Doing great. Excellent finish. The most talented people you will never see on YouTube. People just aren't willing to do it. And I find that funny, that I'm willing to do it, and that's why I chuckle often. How's that? Okay. It's a number 2 jig bore machine made by the Moore Special Tool Company. This machine is like a 1952 and it's working on a 1953 K model. I think that's pretty cool myself. Okay, let's see how we're looking. Just about cleared here. Okay, I think it has full, almost, not quite. Looking at the front, just a little piece there that it's got to knock off. It's a done deal there. Okay. Kick this out of gear. And where'd that caliper go? Right there. Right on the money. Okay, I'll clean this up, get that head out of there, and we'll stick the cylinders on. Back in a minute. Well, the news is good. How about that? That look a little better with them cylinders sitting on there. I'm very happy about that. Very nice. There's a lot more to do on this engine. I'm missing some parts, and I really appreciate the donations, and keep them coming if you can, and I'll get a list and mention everybody by their first names that have donated. I really appreciate it. It will make this happen. But nonetheless, I could easily make 500 videos on Harley Davidsons and not run out of content. Yeah, that's nice right there. Very, very nice. Let's see, let me grab... Hey, this cylinder head. Aren't those cool looking? And they kind of go on like this. I think this is the front head. But anyway, getting closer. Cylinders fit just right. 5 thousandths clearance is what those, the skirt, you know, the part that sticks down in there. Side valve, flathead engine. Thanks for tuning in. More to come.